Hello and welcome to this second lesson of the Introduction to Python unit. Before we start the lesson today, pause the video at this point, take a look at the two diagrams on your screen. I'd like you to work out, please, what are those two things? And there is a fairly obvious clue on the screen to help you. So as I mentioned, this is the second lesson of a 6-lesson series looking at an introduction to Python programming. Last lesson we focused on how to make a basic Python program and how to make the computer talk to us. We're going to take a slight step back today and look at more of the design stage around how do we actually design our algorithms to work effectively before we start the programming process. By the end of today, you are going to understand what flow diagrams are and how they can be used to design complex algorithms. You're going to understand the 4 main symbols that are required to make a flow diagram, and you're going to be able to design a basic algorithm of your own using a flow diagram. So flow diagrams are diagrams used to show the order that events need to happen in a complex algorithm. So we know from our earlier units that an algorithm is a complex set of instructions to solve a problem. A flow diagram will show us what instructions, what processes need to happen and in what order. More than that though, they can show things like where we start and where we stop, any decisions that need to be made, and any inputs and outputs that are needed into the system. Pause the video at this point, go online and see if you can find out what are the shapes of the blocks that are used in a flow diagram for a start and stop symbol, a process, a decision, and an input or output. Pause the video at this point and see if you can find those shapes online. These are the 4 symbols you should have found. So a start-stop block is a rounded rectangle, a rectangle with rounded edges. That shows where our flow diagram is going to start and where our flow diagram is going to end. A process block is a normal rectangle. This shows an action or something happening. An input block is a parallelogram or rhombus. It shows when the user needs to input something or when something may be output from the system. So if we're typing something in, that would be an input. If the computer was asking a question to us, that would be an output. The final block is our kite shape, and the kite shape is for a decision. And that's anywhere in the program where a decision needs to be made. Is a traffic light red? If yes, go one way. If no, go another way. Here is an example. So we're starting with our lamp not working. We've then got a decision. Is the lamp plugged in? Yes or no? If no, plug in the lamp. Now for me that should be a process, so should be a full rectangle block. If yes though, is the bulb burned out? If yes, well, replace the bulb. If no, repair the lamp. Now, all 3 of those kind of mark the end of this process, but at the same time could be process blocks. That will be slightly clearer on the next example. In this example, we leave home and check the time. We then decide, is it before 7 AM? Now, based on whether it is or isn't, we then look at some different processes, either the take bus process or the take subway process. Now in this diagram, those are definitely the correct shape because each of those then move on to another symbol of reach school, which is our end of this activity. So this flow diagram shows you nicely where all of the 4 key symbols could be. We've got an input of check the time, tell the system the time. The system would then check, is it before or after 7 AM? And we then run one of 2 processes depending on which thing was true from our decision block. So at this point I would like you to pause the video and I would like you to make some notes on the 4 flow diagram symbols. I'd like you to explain what each of those are and think of some examples of when we might use each one. So I'd expect to see a drawing of the block, an explanation of it, and then maybe 2 examples of where it might be used. Pause the video at this point and have a go at that activity. You can rewind the video back if you're struggling to remember any of those. So now that we know the blocks, we're probably ready to draw a diagram of our own. Draw.io is a website that allows us to draw really straightforward flow diagrams. You can select the blocks on the left-hand side and then drag them into your diagram. It runs on the internet, so we don't need to worry about installing anything at all. This is what you will see when you open the Draw.io website. You'll have a range of blocks on the left-hand side and a space to draw those in the middle. If that doesn't come up straight away, just click New Diagram and that you'll save that to your device. Have a play around and see what you can draw with those. It should be fairly straightforward. You drag and drop. You can right-click on any to delete as needed. So I'd like you to pause the video at this point, and I'd like you to create a basic flow diagram for the process of driving through traffic lights in a car. Now you'll need to think about any decisions that may need to be made at that point, as well as any potential inputs into the system. You'll need to think about what happens if the light is red, what happens if the light is green, and you may be able to color code some of the arrows by having a play around with Draw.io. Pause the video at this point and see what you come up with. Now this is one of those activities where there is a lot of right answers and probably not many wrong answers. On your screen is an example of a correct answer. We drive up to the traffic lights and we check, is the light green? If no, we wait for 1 second and then repeat that question. If it is, we drive through the lights and end. Now mine is fairly basic, and like I say, there's not really a right or wrong answer to this one. If your diagram makes sense, if it's linked up, if you've used a couple of those different symbols, you're probably on the right track. If yours is nowhere like this one at all, pause the video at this point and make any corrections that you think might be needed. We're now going to think back to our Python programming from last week. When we program, there are 3 main constructs. That means 3 main ways of creating an app or a program. They're called sequence, selection, and iteration. Now, sequence is when one instruction always takes place after the next instruction, or after the previous instruction, sorry. Okay, so instruction 1 always happens, instruction 2 always happens next, and instruction 3 always happens after that. Selection is where an instruction only takes place if something else was true. If the light is green, then do this. That instruction wouldn't always happen next because the light may well be red. Iteration is then when we loop something over and over again, so when we loop over an instruction. That probably makes more sense when we look at an example, so here is one. Our first bit of our program is a sequence. We always start and we always go to step 1. There's no scenario where we wouldn't start and then go straight to step 1. Our decision is then an example of selection. We make a decision, should something happen? We've then got our iteration, which is a loop. We're going to loop over and over again while the light is green. So while the light is green, wait for 1 second and then repeat the selection process. So my example has got each of those programming constructs within it: sequence, selection, and iteration. Now at this point, I'd like you to print off your flow diagram if you're able to, and if not, print screen it into something like Microsoft Word. I'd then like you to label on your diagram the 3 programming constructs showing where each one takes place. Ideally, I'd also like you to add some explanation of what each one of the programming constructs means. Now, if you flick back to the previous slide, you'll better have a look at mine and think about where my different examples sat. Hopefully on your diagram, you've got each of those at least once and will be able to label that on. Pause the video at this point and take a go at labeling your diagram, either printed out in your book or print screened and placed into Microsoft Word. Hopefully this video has provided you with an idea of how we can go about designing our algorithms. In the next lesson, we're going to look at how we can apply this inside of Python, so how we can use selection to allow us to ask different questions and then use different responses based upon their response. So if they said they like dogs, do this, but if they said they like cats, do this instead. Hopefully you now know what a flow diagram is, you know the 4 main symbols, and you're able to design a basic algorithm using a flow diagram of your own. Thank you very much for watching as always. If you have any questions, please do post those either in the comments section below or directly onto Google Classroom. Thank you very much.